The title is Angles in a Triangle. You know, in a triangle, we have three angles. You can see this triangle ABC. See here, we have this triangle ABC. Then we have three angles, A, B, C. So then this triangle has three sides, right? Also have three angles. In a triangle, then this is 3 points ABC we call the vertices. Then this side AB, AC, BC is called sides. Then you know what is the sum of three angles in a triangle? Does everybody know that? That's actually equals. Can you send me? Everybody send me private chat. Don't send it to everybody. Then let me see if you know that.
Wait, can you repeat the question?
What is the sum of interior angles of any triangle?
180.
Yes, that's correct. Very good. Very good. So later, then we'll prove that. Now let's see this example, 2.15. See this problem A, find the measure of the three angles in each of the triangles below. They ask you measure the three angles. See, this is DEF. You can, to measure an angle, you know, what is the 2 we are using to measure angle? We already learned that before, right? What is, can you tell me the name of the 2 you use to measure the size of an angle? What do we call that? Yeah, good. Lucy, you're right. Who else? Jerry, also right. Good. Who else? Yes, that's called a protractor. Protractor. Use a protractor. You can measure the size of angle. Say, if we try to measure each side of angle in this triangle DEF, what is this angle? This angle, you know, I just estimate. This one definitely is about 90 degree. This one I think should be about 60 degree. This one probably that's 30 degree. You can measure it. Now let's see this angle, XYZ. I think this one probably, I have the 2. Everybody, if you have the protractor, you can also measure on my screen. You can also use your protractor to measure on my screen. So now if I measure this angle here, let's see what is this angle equals. This angle equals 70 degree. This one 70 degree. Looks this one equals this, so that means this angle also equals 70 degree. Then that means this one will be 40 degree. Now let's measure what is this angle. We can measure this one first. Now let's see. This is this it's about looks like 30 or 35. This one looks about 30 or 35. 30. Let's see this one. Now let's measure this. This one it's about 130. This is about 130. So this it's about 20 degree. Right? You can measure that by yourself, but Later you will find the sum of the triangle, the three angles inside of triangle always give you 180 degrees. Now let's see this example. Say, given you two lines L and M parallel to each other, they ask you to find the angle BCD, BCD, and BDC, BDC. Everybody send me your answer. What is this angle? What is BCD? What is BDC? See, BDC actually, if line L parallel with line M, BDC with this 70 degree, there are corresponding angles. So this one definitely will equal 70 degree, right? Then in triangle BCD, this is 50, this 70, add together that's 120. So that means this angle equals 60 degree, right? So this one it's very easy. Now let's go to 2.17. So here they ask you prove that the sum of the measures of angles in a triangle is always equals 180 degree. Here they ask you prove that. Okay, to prove this one will separate three steps. They show you three steps to prove that. First, draw a triangle ABC and align K through point A such that K parallel with BC. Okay, that means if you have this triangle, suppose this triangle A, B, C, then they ask you draw a line K parallel with this BC through this point A. Suppose this one's line K. Now make this K parallel with this BC. So that means this one parallel with this BC. Then B, find angles in your diagram that equals angle B and angle C. So line K parallel with BC, then we have this angle equals this angle B, because there are alternative interior angles, right? There should be same. Then for angle C will equals this angle. Also, that's alternative interior angles. Then line K, that's what we draw pass through point A. So that means if we put let's add suppose this one called angle 1, this one called angle 2, this one called that's angle A. We can also call this angle 3. Because line K is passed through A, then angle 1 plus angle 2 plus angle 3 should equals 180 degree, because this one's a straight angle, right? Because line K pass through A, then this line will form a straight angle at point A. So then we get these three angles add together should give you 180 degree. By use this angle 1 equals angle B, angle 2 equals angle C. We combine these three pieces of information, we can just plug in back, use angle B to replace angle 1 and angle C to replace angle 2. Then angle 3, that's actually angle A, right? This one you get a 180 degree. So that means we proved the triangle sum of their three interior angles equals 180 degrees, right? So the key point is here. We already know a line will form a straight angle at a point. Then we convert that the two angles, the partial of that straight angle to the inside of angles of triangles. Then we got that three angles inside of that triangles also got 180 degrees. This is an idea to prove this problem. Now let's go to next problem. 2.18. Say one angle in a triangle is twice another angle, and the third angle is 54 degrees. What is the measure of the smallest angle in the triangle? Okay, so you still need to draw a triangle first. Suppose you draw a triangle something like this. Then let's suppose this that's A, the three verses, that's A, B, C. Now the tag tell you the one angle in a triangle is twice another angle, and the third angle is 54 degrees. So now let's say, suppose this one equals 54 degrees. This one is twice of this. So now let's suppose this one is x degree. This one will be 2x, right? Now we can use sum of these three angles equals 180 degrees. We got a 2x plus x plus 54. This one should equals 180. Then got a 3x equals 126. You got a x equals 42. So the smallest angle in this triangle, that will be 42 degrees, right? So see this problem, usually in the geometry, not only you need to think logically, and also you need to sometimes combine the algebra skills in your process to solve geometry problems. Now let's see 2.19. In this diagram, we have M parallel with N. Say M parallel with N, you add an arrow there. That means this one parallel with this. Then AB perpendicular with M. So you put a little square here. That means this line M perpendicular with AB. And angle ADC equals angle BCE equals 3 times of x degree. The angle CEB equals 50 degree. And the angle BCD, this one equals x. Then they ask you to find the x. Okay, everybody try this. Now let's see. We need to. They ask to find what is x. So then, to do that, now let's see. First, this line parallel with this line, so that means this angle also equals this angle, also equals 90 degrees, right? Because this angle and this angle are their alternative interior angles. So if this one is 90 degrees, that means this angle also 90 degrees. Now in triangle ABE, they give you this angle equals 50 degrees. That means this angle equals 40 degrees, right? Now say this one it's in triangle ADC. This angle is 3x. This angle is 40. So what is this angle? Because sum of these three angles should equals 180. So that means this angle equals 180 degree minus 40 degree, then minus 3x, right? So we got this angle. Then, you know, ACE, that's a straight line. So that means AE form a straight angle at point C. So then we have this angle plus this x plus this 3x should equals 180 degree. Then we got an equation regard to x, then we can solve that equation. So now we can write down this 180 degree minus 40 degree minus 3x. This is this angle, right? Then plus x plus 3x. Then this should give us 180 degree. So then we cancel out this 180, cancel out this 3x. So then we got x equals 40 degree. So that means x equals 40 degree, right? So solve this kind of problem. Always try to find, write down all the angles you can find in your diagram. Say, when they tell us m parallel with n, then this angle is 90 degree. Then you can immediately write down this angle also equals 90 degree. This one equals 90 degree, then you in triangle ABE, this will be a right triangle. Then you have this angle A will equals 40 degree. 40 degree, then you think in triangle ADC, you can express that this angle ACD use 180 minus 40 degree, then minus 3x, get this angle in x. Then plus x plus 3x, then you should get a 180 degree again. Then solve this equation. You get x equals 40 degree. Now let's see. Actually, we already finished this this section. This section is kind of easy. Now that will be the exercise problem will be a homework. Now let's go to next section. 2.6 exterior angles. This one is very important and also very useful. So here in this example, we still have a triangle ABC. See this picture. ABC. Then if we extended this side BC to another point D, now we'll form an angle ACD, this angle. This angle we call it's exterior angle of triangle ABC at C. You know, here ACB, that's called, this one called the interior angle of triangle ABC, right? Then ACD we'll call the exterior angle of triangle ABC at C. Then they ask you what is this angle equals. So to find this one, you know, first in this inside of this triangle, they give us these two angles. We can find this interior angle C by use 180 degree minus 35 degree minus 79 degree. Then we can get this one, let's say 180 degree minus 79 degree minus 35 degree. This one will equals say 66 degree, right? If you add these two together, that will be minus 114. 180 minus 114 got 66 degree. This one equals 66 degree. Then you use straight angle formed by this line BD at C. So that means you can get angle ACD will equals 180 minus 66 degrees. Then you got this one equals 114 degrees, right? Because this angle plus this angle equals 180 degrees. So that means this x equals 114 degrees. So this is a normal way to calculate this. Actually, here we have a shortcut. You compare this x with the sum of these two angles. See, you can get this x actually also equals sum of these two angles. That's equals 114. So then, when we write this, actually you can write this one 180 minus 66 degrees. That's what we do this algebra here. You can plug this one 180 minus 79 degree minus 35 degree. Then you can open this parenthesis. You can get this one equals 79 degree plus 35 degree. So by this way, we proved exterior angle actually equals sum of two interior angles is not adjacent with 8, right? See, this exterior angle equals sum of other two interior angles not adjacent to 8, right? So this one actually is it's a fact, it's a theorem. You can use it later. It's very useful when you try to solve some problems. Now let's see, prove angle x and angle y equals angle xzp. So see here, exactly they ask you prove this exterior angle equals sum of these two angles. Okay, to do this, actually I already show you the process to do this. First we can find the angle xzy. This one equals 180 degree minus angle x minus angle y, right? Because in this triangle AB XYZ, this angle, this one equals 180 minus angle x minus angle y. Then we can calculate angle xzp. This one will equals 180 degree minus this angle xzy. Then you plug this one to replace here. You got a 180 degree minus 180 degree minus angle x minus angle y. Then you open this parenthesis, you got this one equals angle x plus angle y. So we proved, we are done. Okay, very easy. Now let's see this example. This one said in the diagram below, AB parallel with DE. See, they add this arrow to represent these two lines parallel to each other. The angle BAC, this angle equals 2x minus 20. Okay, this angle. And ACB equals 30 degree. And angle DEF, this one equals x plus 55 degree. Then they ask you to find the CED. They ask you to find this angle, this one. CED equals what? Okay, to find the CED, definitely you can also use straight angle. Say, because they give you this angle equals x plus 55 degree, right? So that means this angle, we can write this angle CED actually equals 180 degree minus this x plus 55 degree minus this. but then we still have this x here. Then when you get this, write this angle. Now let's see. They give you this one. This one, because this line AB parallel with DE, so this angle should equal this angle, right? And also this angle equals 30 degrees. That means this angle also equals 30 degrees, right? So then in triangle CDE, you know this angle, we know this angle equals 2x minus 20 degree, right? Then we already represent this angle equals 180 minus this one. But actually the shortcut, you can use this one. This one is exterior angle of this triangles at vertices E. So that means we can write the equation x plus 55 degree will equals 30 degree plus 2x minus 20. So say when we write this one, you say, oh, this is so easy. This exterior angle, this one equals sum of these two. We just learned that, right? So get x plus 55 degree equals 30 degree plus 2x minus 20. Then you solve this equation, simplify first. Get x plus 55, this one equals 30 minus 20, that's 10, then plus 2x. So then both sides minus x, you got x, then minus 10, you got a 45 degree. So you got x equals 45 degree. So then that means they ask you this angle. This angle that's equals 180 minus 40 minus x plus 55. So that means we get this angle CED equals 180 degree minus x, that's 45 degree, then plus 55 degree. Add these two together, that's 100 degree, right? So 180 degree minus 100 degree, then you got this angle equals 80 degree, right? We got this one equals 80 degree. So say if you don't use this exterior angle, then you can also, as what I write, use this one, that's angle CED. Then you plus 30 degree plus this 2x minus 20, add together, you get a 180 degree. You can also do that way. But if you know this exterior angle equals sum of these two angles, you get this equation. It's much easier than the other one. If you do the other one, that will be like this: 180 degree minus x plus 55 degree, then plus 30 degree plus 2x minus 20 degree. This one should equals 180 degree. You got this. If you don't use sum of exterior angles, you got this. Compare this one with this. See, this one looks much easier. Okay, so then you can see the exterior angle. That's very useful. Now here, it's a very interesting problem. Say in this triangle ABC, we have three exterior angles. That's x, y, and z. Then they ask you to find what is x plus y plus z. Everybody, can you try this? Okay, can you try this? Now, to calculate angle x plus angle y plus angle z. Look, somebody sent me answer. Now let's check. Yeah, Matt, simplify. Give a final answer. Does not matter. This is not a equilateral triangle. But you can suppose that's an equilateral triangle. Then that'll help you to think what is the correct answer. But actually, we don't limit it. That's equilateral triangle. There can be any triangle. Yeah, Matt, you get the correct. But then you think, actually, you just got your answer from a very special case. Actually, we don't require that has to be a equilateral triangle. That can be a very general triangle. Suppose I just draw like this. Now, suppose this triangle is this, A, B, now let me extend it this one, go to this direction, then A, B, C. So this angle is X, this angle is Y, and this one is Z. Now we can find sum of these three exterior angles. Now let's do it. Okay, to do that, now let's see what is X. X will equals 180 degree minus this angle A, right? Minus angle A, minus this one. If you try to write this exactly, you can write CAB. Okay, use three letters. We represent this angle. 180 degree minus this angle, right? This is X. What is Y? Y equals 180 degree minus angle B, minus ABC, right? This angle Y, this Y equals 180 degree minus ABC. So what is Z? Z equals 180 degree minus ACB minus this angle, right? Minus this one. So then you add these three equations together, you get the left side, that will be X plus Y plus Z. Then see what is the right side. Right side, that will be 180 plus 180 plus 180, that's 540 degree minus sum of interior angles of this triangle ABC, right? That's CAB plus ABC, then plus ACB. Then we know the sum of interior angles of triangle equals 180 degree. So you got a 540 degree minus 180 degree. Then you got this one equals 360 degree, right? So the correct answer is 360 degree. So for this way, say we don't require this triangle has to be an equilateral triangle. This triangle can be any triangle. They always true. Then you can think this one actually is very interesting. You know, if you try to understand why this one equals the sum of these three angles equals 360 degree, you can imagine. Suppose you stand on the vertex A, start from vertex A, then move the walk to point C, then walk to B, then return to A. You actually, actually the angles what you finish is like circle. That's 360 degree. Suppose you face this direction here. Then at the beginning, suppose you face to this direction. When you walk along this triangle, when you go back to this A, then you return to this direction. So in this process, you made a 360 degree. If we don't consider the distance you walked, we just consider the directions you walked. That's actually 360 degree. Does not matter what shape of this triangle is. If you just walk along this triangle, start from point vertex A, return to vertex A, then the direction you made, that's 360 degree. You can understand like this way. Now let's go to this. Then we already finished this section. Now let's go to next section. This section is 2.7, parallel line revest. So that means we still have something to talk to you about the parallel lines, because this one we'll use a lot in our later chapters. See this example, 2.24. In the first diagram, in this diagram, what can we see about the lines K and M? K and M parallel to each other, right? Because this angle equals 40 degrees, this also equals 40 degrees. So here, they just try to teach you, the previous, the section where we learn about the parallel lines, they tell you these two lines parallel to each other. Okay, the first they give you said this line parallel with this. Then you know these two angles are congruent or equal, right? Because these two angles are corresponding angles. Now we go backwards. We did not tell you these two lines parallel each other. We only give you these two angles are same, or equals 40 degree. Then we ask you what is the relationship between this line M and line K. The conclusion is they are parallel to each other. So that means the parallel is equivalent to the corresponding angles congruent. These two conditions exactly equivalent. From one, you can get another one. If we know these two lines parallel to each other, we can get their corresponding angles are congruent. Now, if you give us two corresponding angles are congruent, then we can get these two lines parallel to each other. Okay? Then they ask you why. If they already found this one parallel with this, then B asks you why. Okay? The reason is here we can prove this one use contradiction. That means if we suppose that's not satisfied, then we'll get some strange, weird things happen. Okay, so now let's see what we can get this one weird thing happen. Now, say this angle equals 40 degrees, this angle equals 40 degrees. We are guessing this line K will parallel with this line M. Maybe you said, no, maybe they're not parallel to each other. Okay, now let's say if you don't agree with me, I'll give you a very weird result. Will conflict with what we already know. Now let's suppose line K is not parallel with line M. Then line K will intersect with line M somewhere. Okay? If you said these two lines not parallel each other, that means they will intersect somewhere. Now let's suppose they intercept at a point R. Then that means the line, this is the line M, this is the line K, and this line X PQ, this PQ will form a triangle, right? They will form a triangle PQR. Okay, so then now let's say this is this angle is exterior angle of triangle PQR at vertex P. Right? See, this angle will be an exterior angle of triangle PQR at vertex P. You know, we already know this angle should equal sum of this one with this. So that means 40 degree equals 40 degree plus angle PRQ. This angle equals this one plus this one. So that's 40 degree plus 40 degree plus PRQ. PRQ. So then by this way, we get the PRQ equals 0 degree. So then in a triangle, all of the angles should be greater than 0. How in this triangle you have an angle equals 0 degree? If it equals 0 degree, that should not be a triangle. So this is a contradiction. So what is the reason cause this contradiction? Because you assume this line K is intercept with this line M somewhere. Then they'll form a triangle. Actually, if you don't assume that's intersect with line M, you accept that parallel each other, then we cannot get this contradiction. So the reason we get this contradiction just because we made the wrong assumption. So that means line K should not intersect with line M. That means they should parallel to each other. Okay, now you get it? So contradiction also very, very powerful. A lot of times, if you use contradiction, then you can prove your result very easily. Now let's see example 2.25. Given that angles have the measure indicated in the diagram, in this one, ask you prove AB parallel with CD. So, and also prove BC parallel with AD. So here in geometry, this one is very powerful. You know, also it's very interesting. When we prove something in the previous, then you can use that as a fact in your current problem. See, in the previous problem, we already proved if you give us corresponding angles are equal, then we can get these two lines should parallel to each other, right? So now you ask us to prove this line AB parallel with CD. So that means if we can find their corresponding angles are equal, then we can get our conclusion. So then now let's see if we can get the corresponding angles are congruent. Now let's see. In this diagram, they give us this angle BAC equals 70 degree. This one 70 degree. This one is 80 degree in triangle ABC. So that means this angle will equal 30 degree. Right? Then we also can get this angle in triangle ADC. This angle will equal 70 degree. Right? 70 degree. Then you can extend it you can extend this line AC. Suppose you extended this line AC like this. What I draw, this one's not good. I need to make this overlap each other. Suppose I extended this line AC like this. Then I also extended this line AB this way. Then now let's see. You know, this angle will equal this angle because they are vertical angles. Vertical angles, that means they have the same vertices but opposite. So this angle equals 70 degrees. So this angle is corresponding with this angle. They are all equal 70 degrees. So that means line AB parallel with CD. Because in the previous problem, we already proved if you give us two corresponding angles are congruent, then we can get the two lines parallel to each other. Then here we have these two corresponding angles equals 70 degrees. By we extended this line AB and AC, we formed these two corresponding angles. They are all equal 70 degrees. So that means this two line AB parallel with CD. Then we can also prove AD parallel with BC. Use the same way. You can also extend it AD. Maybe you can also extend it CD. Just up to you. The idea just try to form two corresponding angles. You know, say to prove AD parallel with BC, then we can say this angle will corresponding with this angle, right? So this angle equals 80 degrees. Then CD, that form a straight angle at point D. Then that means this angle AD, suppose this one is E. This ADE will equals 100 degrees. Then say this is 70 degrees plus 30 degrees. Then we got this angle also equals 100 degrees. Say this angle that's BCD equals angle ADE. They all equals 100 degrees. Now see the position of these two angles. They are corresponding angles. So that means from this we can get a line AD parallel with line BC. Right? So the idea is very straightforward. Just to build two corresponding angles. Then these two corresponding angles, if they're same, then these two lines are parallel to each other. By just extending this two lines, then we can get the two corresponding angles are congruent. Then we prove these two lines parallel to each other. So then we finish this section. Actually, now let's see. We also finished this chapter. Now let's summary. In this chapter, what we learn, that's angles and vertices and triangles, right? So if you have two rings start at the same vertices, then you form an angle. We call this vertex its origin of this angle. Then we call this OX and OY, that's two sides of this angle. Then later we learn the triangle. We learned in these angles we learned the right angles. That means the measure of that angle equals 90 degrees. That means two sides of this angle perpendicular to each other. Then if an angle less than 90 degrees, we call that acute angle. If that angle is between 90 degrees and 180 degrees, we call that obtuse angle. If angle is equals 180 degree, that's straight angle. We call that straight angle. If angle is more than 100 degree, we call that reflex angle. This one we did not use a lot. Then if two angles, if they add together, get a 180 degree, we call their supplementary angles. If the two angles add together get a 90 degree, we call that complementary angles. You can use, say, this is C. This start first, right? If in the alphabet, C come out first, then S. So then come out earlier, that's 90 degree. Come out later, that's 180 degree. So by this way, you can help you memorize what is a complementary angle means. If you add together, you get the 90 degree, that means they're complementary angles. If you get the sum is 180 degree, that means they're supplementary angles. Then vertical angles. Vertical angles, that means they have the same vertices but opposite to each other. That means they are exact same. Their measures, they're same. Then we learn the parallel lines. The two parallel lines, if have another line intersect with these two parallel lines at 2 points, then at these two intersection points you will form 8 angles. Then you can get the relationship of these 8 angles like this. Okay. Then later we learn triangles. Triangle, you have 3 angles. The key point, that's a sum of these 3 interior angles of triangle equals 180 degree. Then later we learn a very important theorem. The sum of 2 interior angles equals the exterior angle not adjacent that inside angle, like this. So you can also say exterior angle equals sum of the other 2 interior angles. This actually is see, they also give you example proof by contradiction. This one is very powerful. In math, we'll learn this. We'll use this one a lot of times. So then we finish this chapter. Yeah, we finished this chapter. Now you need to finish the homework. You also need to finish all the review problems. Now let's see if we can pick some review problems, or we can do some challenge problems. You know, each chapter, except the review problems, we also have challenge problems. Now let's see here. Okay, let's try to solve this. Let's see some harder problems. Okay. Yeah, this one I think is interesting. Find these 4 exterior angles, sum of these 4 exterior angles. Everybody, do you know this one? This one for general quadrilateral. Suppose this one is A, this one is B, this one is C, this one D. What is the sum of these 4 angles? This one conclusion is also equals 360 degree. So how to prove this? To prove this, you can do this. Write similar way. Write angle x. Angle x will equals 180 degree minus u equals 180 degree minus angle like DAB. minus this angle A, right? Then you can get a y equals 180 degree minus angle ABC. You can get the z equals 180 degree minus angle BCD minus this one. Then you can get W equals 180 degree minus angle ADC minus this one, right? Then you add these four equations together. Left side you get a x plus y plus z plus w. This one equals 4 180 degree. That's 180 degree times 4. Then minus this one will be sum of these four interior angles of quadrilateral. You know, for quadrilateral, the sum of their interior angles equals how many degrees? Then you get this one that equals actually angle DAB plus angle ABC plus angle BCD plus angle ADC, right? This one, you know, for any quadrilateral, because the formula for polygon that's equals 180 degree times n minus 2. This n is a number of sides of that polygon. Then you can check for a triangle, this n equals 3. So 3 minus 2, you get a 1. 1 times 180. So when n equals 3, you get a 180 degree, right? That's for triangle. When n equals 4, you got a 4 minus 2. That's 2. 2 times 180, you got 360 degree, right? So then you understand the sum of all interior angles of quadrilateral that's equals 360 degree. Then you got this one that's 720 degree minus 360 degree. Then you got this one will equal 360 degree again. So this one it's very interesting. See, for we already proved for a triangle the sum of their three exterior angles equals 360 degree, right? For sum of exterior angles of quadrilateral is also equals 360 degree. Then maybe you guess for any polygon, maybe that's hexagon and pentagon, whatever, the sum of their exterior angles also equals 360 degree. Is that true? You can guess. Everybody say, is that will be true? The answer is yes. You know why? You can think like this way. Suppose you start from the vertex A, first is this direction, go around along this pentagon, then when you return to here, in the direction, you always walk to 360 degree. This is the reason. Always 360 degree. So then everybody, we already finished this chapter. Your homework, that will be all the exercise problems behind each section and also the review problems, all the review problems in this chapter. For the challenge problems, you can try if you like. If you don't have the time, you also don't like try, that's fine. So time is up. We can stop here. Everybody